Good morning, everyone. My name is Jhoana Agudelo, and my advisors are Paula Arias y Sara Vieira. And this work is a collaboration with John Alejandro Martinez. Well, uh, as motivation for this study is that the variability of the Amazon and the ecohydrological services provided by these rainforests depends on inadequate moisture supplies during its dry season and the transition months, September, October, and November, to the wet season. So the dry and transition seasons constitute an important and a fundamental stage to the hydrological cycle in the Amazon. We have that the recent studies report a lengthening of the dry season, over the southern Amazon. This is observed during the last few decades, consistent with more frequent occurrence of shorter wet seasons in these regions, a reduction of precipitation rates, and an expansion of the savanna ecosystem, also in these southern regions of Amazon. For example, the study realized by De Bortoli et al. In 2015 shows decreased trends in a duration of the Amazon rain season in these yellow circles. Besides this, other modeling studies indicate that deforestation of the Amazon rainforest can contribute to a dry season lengthening in these regions too. Well, another studies suggest that the dry season lengthening is related to other phenomena such as the early retreats of North American monsoons and late onsets of South American monsoons. These things can induce a variation in regional circulation patterns, making local conditions drier here over the Amazons. So, for example, Arias et al. Suggest an increase in the surface convergence in these regions, in the Caribbean Sea. These changes are due to changes on regional circulation, maybe, and something important to this study is that the authors are focused on the dynamical processes, but not on the moisture transport. So for this reason, we ask the question, how a possible lengthening of the dry season in the Amazon can affect the moisture transport toward the North and South America, and we addressing these questions from the hypothesis that the longest dry season in this forest occurred in association with an intensification of surface convergence in the equatorial region or in the Caribbean Sea. And we want to know if can it be verified through an analysis of moisture trajectories. Well, to do this study, we use era interim reanalysis. We use daily data during the period between 1980s and 2010. We use precipitation, evaporation, precipitable weather, and vertical integrated moisture flux for both zonal and meridional component. These variables were used to implement the dynamical recycle model, or DRM. This model is implemented to calculate the trajectories that follow the atmospheric humidity. And we follow a Li and Fu methodology to calculate the years with longest and shortest dry seasons. This is the methodology that Natalia shows in her presentations. In this table, we can see we use the criteria of 75% of the standard deviation. In this table, we can see the results of the years with longest and shortest dry season in the Amazon during our study period. And here we can see the domain that we used to implement the model, the DRM. The domain is divided into 21 subregions to study the atmospheric moisture transport. Well, well, in order to identify the spatial distribution of the atmospheric moisture, we estimate the total precipitable weather contributions from continental, oceanic, and all regions that we saw in the domain. We composite them from longest and shortest dry seasons, and we estimate the difference between both. So, thus, the positive difference, or blue colors, indicate increase of moisture transport during the longest dry season, while red colored, or negative difference, indicate a reduction of moisture transport. So in this figure, we can see the difference between longest and shortest dry season composites from September, October, and November, which are the months of transition periods in the Amazon. Um, the results show us an important increase of moisture, of atmospheric moisture over North and South America and the Caribbean Sea in this figure, and we can see that this increase of moisture transports are related with enhanced moisture coming from the oceanic regions in this row, rather than from the continental sources in this row. Well, another important feature in this figure is that we can see a significant reduction of atmospheric moisture over South and Southwest Amazon, especially during September and October, the first 2 months of the transition seasons. This reduction is related with a reduction of moisture transport from continental sources, we see here, especially with a reduction in moisture recycled from the southern Amazonian rather than from oceanic sources. Well, the latter is better observed in these figures. This diagram shows that an important reduction of recycled moisture over southern Amazon, especially when we consider longest dry seasons, the blue line, especially when we show the first 2 months of the transition seasons, September and October. And this reduction is also shown when we analyze evapotranspiration from era interim in this figure, and we can see that in these problematic regions present to an important reduction of evapotranspiration. Well, the reduction of atmospheric moisture over Amazon and the increases over the Caribbean Sea and northern South America that simulated by the RM is also, or is in agreement with, the precipitation change that shows other observational data such as precipitation from CMAP, GPCP, and Persian data. Well, also we analyze the Hadley and Walker regional circulation in order to identify if a lengthening of the Amazon dry season could be linked to significant change in these regional circulations. So in this figure, we can see the mean vertical cross-section of the regional meridional divergence circulation in the vectors. and mass stream function over South America, that is the shaded or the colors, during the longest, shortest dry season and the difference between both. So we can see that the upward motion is located near the 5 degrees south, 5 degrees south for both cases. And we can focus, when we focus on longest dry seasons, we can see an enhanced ascending motion over the equatorial regions here, but we can see to an increase of downward motion on subtropical South America. Well, in this figure we see the regional circulations, the regional water circulation, again during the longest dry season, shorter dry season, and the difference between both. We see that the ascending motion is between the 40 and 80 degrees west for both cases, and the descending motion is over the oceans between the 20 and 40 degree west for both cases too. But when focus on the difference, we can see that, well, we can see that the longest dry season exhibit a stronger upward motion over the over the 60 and 80 degrees west, that is in these regions, is in agreement with this pattern here, increase the moisture flux, and we can see two intensified subsidence over the eastern Amazon in this region, something important because it's in agreement with this pattern here of decrease of atmospheric moisture content. Well, finally, we analyze, or in this figure, we presented the easterly waves track density, again for longest dry season, shortest dry season, and the difference between both. And in this panel, we can see in yellow colors that during the longest dry seasons, increase the numbers of easterly waves that are arriving to the Caribbean regions here, coming through the equatorial Atlantic oceans. So this pattern is important because corroborates the idea that the increased moisture over Caribbean regions is mostly related by dynamical processes originated over oceanic regions. Well, some discussion. We can see that in fact, our results shows an increases of atmospheric moisture over northern South America and the Caribbean regions. We can see that these increases are related to enhanced moisture transport from oceanic sources, mainly from the tropical North Atlantic. Reduction of atmospheric moisture over the southern Amazon are related to inhibit moisture recycling in the regions, particularly during the transition periods. We can see that the mainly effect is during the September and October months. And the longest dry season in the Amazon are associated with enhanced moisture transport toward northern South America and the Caribbean regions, and reduced moisture in the southern Amazon. The analysis related with the Hadley and Walker regional cells suggests that these regional circulations are straining during the occurrence of longest dry season in the Amazon. Thank you.